Next up is the Lewis structure and the VSEPR geometry for silicon tetrachloride. Again, let's start with the number of valence electrons to build the Lewis structure. Silicon comes in with 4 valence electrons. Each chlorine comes in with 7. There's 4 of them. 4 times 7, 28, plus 4 is 32 total valence electrons to work with. Let's put silicon in the center because it's less electronegative than chlorine. And we'll surround it with the 4 chlorines. Next step, we're going to combine or connect the terminal atoms with the central atom. That's each of these covalent bonds are going to use up 2 electrons in those bonding pairs. That's going to use up 2, 4, 6, 8 of our available 32. So we're down to 24 valence electrons. Let's give the terminal atoms an octet. Each of the chlorines already have 2 in the bonding pair, so they would each like 6 more to achieve the octet. And that's going to use up the remaining 24 valence electrons. So here's your Lewis structure for silicon tetrachloride. Now let's go over to VSEPR theory, which says around the central atom, which is silicon here, you have 1, 2, 3, 4 regions of electron density, also known as the steric number. And that will lead to and since they're all bonded, in other words, you have no lone pairs. When you have 4 regions of electron density and there are no lone pairs, then that geometry is tetrahedral with bond angles of 109.5. Let's just draw that using the line. So the lines indicate bonds on the plane of the screen. It was chlorine, I believe. And then if you use a wedge, that indicates it's coming out at the screen. So I'll try to draw that a little bit bigger. And then if you use the dash, it means it's kind of going behind the screen. So I'll do that a little bit smaller. All right, each of these, let's not forget their valence electrons. And so the bond angle here between any one of these is 109.5, known as tetrahedral.